Alright, my meeting moved to tomorrow. Which I think it's tomorrow at 9, I think. Damn it. I should check my phone here. Tomorrow at 9 my time. Yeah. Okay. We'll do 3 to 5. And then my D&D session was also canceled, so I'll just delete that. And what we'll do is a quick dinner. 5:45 maybe to 6. Actually, we'll do this at 5 to 5:40, 5:15. And then, where did that go? I hate it when it does that. Decides PM. If I'm already on PM, I don't want to switch to AM when I go to edit. I want to stay on PM. But the UI is broken. See, watch, 5 PM. It should be 5 PM like this, but for some reason, sometimes it does AM here. Anyways, 5:15 to 6. It's a lot to cram into an hour. Dinner, cardio, groceries, and taking out the garbage. But that's all the time I have. Oh. And then evening stream will be from 6 to 8 PM today. Okay. I did my hit right here. And then this was a big waste of time. Waste time. Same thing here. Waste time. Actually, no, I can't say that. This is social time with on Signal. I don't want to penalize myself too much for spending time with chatting with friends. Breakfast was definitely earlier than that, though. I think breakfast is more like this. Okay. Cool. All right. We were reading about P-Trace. And what was this? I wanted to review this. 10 years and 3 months ago. Wow. people really understand this stuff? Why does it just say over a year ago? That's like infinite time. Can't you give me a fucking date that's more precise than that? There we go. 2017. The gay Russian Putin dude is the one with the long answer. Well, you can have a dynamically linked non-pi executable. Was this guy recent? 2019. Somewhat recent. I doubt that Linux is using the C23 standard yet. These are all header files, no actual C files. Yeah. And the auto here I think means something else, right? Let's see what version of grep can do this. Like that. No. Can do 99 just for testing. What type of build system does Linux use? Kbuild. That's right, they have their own kernel build system and a make file. It's actually a really fucking clean repo. Compared to CPython, like this is a lot cleaner. Why does documentation have a capital D? Why can't you just do a lowercase consistency? Rust. That's like the big controversy. Ultimately, Linux is just a tree of files. That's what Linux is. A tree of source code files. One that is, let's see, get submodule list. Do they even use submodules? Status? No, they don't even use submodules. Does Linux use get submodules? And if it doesn't, did it ever? IOUring has its own directory. Interesting. Wow, lots of code. Not deeply nested though. Sorry, find. Yeah, it's all just in this directory. If we grep v.h, everything else is C, except for a make file and kconfig, kconfig grep make file, and grep obviously of the permissions. I think we can do it better like this. Okay, it's all C code there. So, boop. If we take all of these, just cat them together. Oops. Do it like that. 22,000 lines of C code. I mean, it's not a small amount. What does the kconfig on this look like? Okay, so this is just kernel configuration. It's nothing crazy. There's also, is there a Linux? No, it's not a Linux directory. So where are they getting this elf from? elf.h. And is there a Linux? Grep Linux. There's a lot of elf.h's. There it is. Include Linux. So include Linux elf.h. So I wonder how that differs from user include elf.h. elf.h. There you go. Looks very different. This is a Linux elf.h. This is elf.h. These are 1 for the. It's very different. I mean, it's not a hard format to parse. This one's only a 112 line header, whereas this one is the standard. It is 4,400. That's why they wrote their own. They're like, we don't need all this shit. It looks like they pulled in some of the stuff they needed here, like elf half and elf word. It's a bunch of pound defines. I don't see really. There's a little bit of code here, or a little bit of yeah, that is actual code. I don't see any structs that are really interesting here. I thought it would have more. I guess they're pound including this stuff here. UAPI Linux elf.h. Let's check that in. Or check that out. UAPI. That might be the user API. Linux elf.h. This is probably where the structs are. Hopefully. Yeah, we get nice structs here. That one's a little bit longer, yeah. Alright, that's enough poking around Linux. Do we want to finish reading this stuff? Maybe while we were seeing that the subshell not getting a new randomized text section address is because the $$ was evaluating to the actual shell, the parent shell, not the child shell. So if I echo $$ here, and then I do bash C, and I do echo $$ here, it's going to be the same value. If I do this as a single quote though, I get the subshell. So then in here, if I say something like cat proc $$ maps, and then I'm just going to grep for, this will be cat, and grep for our r-xp, this will be our text section. So every time I run this, now we're getting a different randomized address. It's the evaluation of $$, that's why it was fixed. It does happen every time I run it. I was being a goofball earlier. Should have realized that. Cool. So ASLR works for, at least cat is position independent. So if I do type, or say file on what is cat? Which cat? File user bin cat. That should be position independent. Yeah. And if I do read elf on the header of that, there we go. So most binaries generated today are, most modern binaries are going to be position independent, dynamically, well, with the dyn type in the elf header, whether they're executables or shared objects. I think the difference really comes down to whether they have the interpreter field. When was this book published that I'm reading here? I need to start getting more up-to-date shit because the books I've been reading are like the oldies and they're not really like up-to-date on stuff. This is 2016. So I'd probably do better if I started reading more up-to-date shit. Okay, let's continue reading here. Using the tracer program. So we had, let me kill this. I gotta do some cleanup here. I got too much stuff going on. What's going on over here? Is this the tracer? Yeah. But we'll kill it for now. I need to do some cleanup here. I need to finish reading these Stack Overflow links and pop the stack here. So it says there's effectively two types of ET. Let's go from the top here. Put a little bookmark in here. Alright. This logic is run once for the first load program header for the ET-DYNE binaries to calculate the randomization load bias for all load program headers and to calculate the entire size of the ELF mapping. Total size. Note that load adder set is set to true later once the initial mapping is performed. There are effectively two types of ET-DYNE binary programs, i.e. pi ET-DYNE with interpret and loaders ET-DYNE without interpret. So there are effectively two types of ET-DYNE binaries. Pi with an interpreter, that's what I was saying before, and loaders since they are the ELF interpreter. Okay. The loaders must be loaded away from programs since the programs may otherwise collide with the loader, especially for ET-exec, which does not have a randomized position. So if you look here, you can invoke the loader directly. This is interesting. I've never done any of this stuff. Damn it. Huh. Does the same thing as LDD. What the fuck? It's a different inode. They're different programs, but they output the same. At least the dynamic linker seems to have more functionality, so let's continue playing with that. Okay, so you can change arg v0 in the exec. I don't know what any of this shit is. It's a lot of information. Okay. So when you call the syscall exec on a ELF binary with an interpreter, the Linux kernel it execs the interpreter and not your binary directly. So it'll load up the interpreter ELF into memory. It's a dynamically shared object, so it's loaded in a position independent random location. And then some entry point code was invoked. It reads argv and environment, and then it loads your code from your ELF, which is probably an argument, into the virtual memory address space of the current process, and then it jumps into your entry point that you have to find. That's my understanding. If you want, I can keep you here all day. Alright, let's continue reading. Wow, this guy really went into it. I feel like I've seen this before. Is that just something people put on their profiles because they don't like Putin? I feel like I've seen that before. All right. File 536, and this is file 536 source code. Okay. After studying how file works in source, we conclude that if the type is exec, it is print executable. If it's dynamic, if the DT flags dynamic section entry is present, and if it's pi, the df1 pi is set in the flags, then it prints pi executable, else it prints a shared object. And if there are no flags, if the file is executable by a user group or others, then we print pi executable, else we print shared objects. So it's very kludgy the way it works. Like most things in Linux, there isn't like a strong concept of a executable. Like containers are not a concept in Linux. It's like all these primitives that get put together to make containers. And there are other examples of that in Linux. Generally doesn't actually contain the idea that people talk about in Linux. Linux generally just does the general thing. And like in this situation, it has to be an elf binary. And the elf binary has to have one of two different types, dyn or exec. But as long as it does the right thing, doesn't matter if it's marked as exec or not. So this is the default, which is fpi and pi. It gets all that, so it says pi executable. If you say no pi, then you get an exec. Those things are not emitted, and it just says, hey, it's executable. If you say, hey, I want a shared, then it's a shared object. It's not executable. In which case, you don't get the flags, you don't get the pi. You do get a plus X on the chmod, which I don't understand why. Oh, that's if you choose to add it or not. If you don't have it, then it's a shared object. So then I wonder what happens if I do file on user libc.so.6. It says shared object, even though it has the interpreter, because it's not position independent, or it doesn't have the position independent flag. Doesn't mean that the code is position independent because it's a shared object. The regular LD loader will just give you executable. But if you say pi with dynamic linker or no dynamic linker, it doesn't matter. It'll still report as pi executable to file. Okay. I don't really want to do a full source code analysis here. I think I'm good. Alright, let's close out of that. Let's do a skim on these. 32-bit absolute address no longer allowed in x86-64 Linux. 64-bit Linux uses a small memory model by default, which puts all the code and static data below the 2 GB address limit. This makes sure you can use 32-bit absolute addresses. Older versions of GCC use 32-bit absolute addresses for static arrays in order to save an extra instruction for relative address calculation. However, this no longer works. If I try to make a 32-bit absolute address in assembly, I get the linker error relocation so-and-so against data cannot be used when making a shared object recompile with fpic. This error message is misleading, of course, because I'm not making a shared object and fpic doesn't help. What I found out so far is that GCC version 4.8.5 uses 32-bit absolute addresses for static arrays. GCC version 6.3.0 doesn't. Version 5 probably doesn't either. The linker in bin utils allows 32-bit absolute addresses, but version 2.28 does not. The consequence of this change is that old binaries have to be recompiled and legacy assembly code is broken. Now I want to ask, when was this change made? Is it documented somewhere? And is there a linker option that accepts a 32-bit absolute address? Your distro configured GCC with enabled default PI, so it's making position independent executables by default, allowing for ASLR of the executable as well as libraries. Most distros are doing that these days for security reasons, obviously. You actually are making a shared object. Pi executables are sort of a hack using a shared object with an entry point. The dynamic linker already supported this, and ASLR is nice for security, so this was the easiest way to implement ASLR for executables. 32-bit absolute relocations aren't allowed in an ELF shared object. That would stop them from being loaded outside the load 2 GB for signed extended 32-bit addresses. 64-bit absolute addresses are allowed, but generally you only want that for jump tables or other static data, not as part of instructions. Yeah, because it's not position independent. Basically, you don't want to do absolute addressing. The recompile with -fpic part of the error message is bogus for handwritten ASM. It's written for the case of people compiling with GCC-C and when trying to link with GCC-share-ofo foo.so star.o with a GCC where fpi is not the default. The error message should probably change because many people are running into this error when linking handwritten ASM. The correct way to interpret recompile with fpic is make new ASM that's Pi compatible, either with a compiler from C source or by hand if your source is ASM. How to use RIP, relative addressing basics. Always use RIP relative addressing for simple cases where there's no downside. See also footnote 1 below and this answer for syntax. Only consider using absolute addresses when it's actually helpful for code size instead of harmful. NASM default rel at the top of your file. AT&T or guess. Okay. So you can say foo relative to RIP, which is an offset of RIP, which is the address of the next instruction. Disable pi mode to make 32-bit absolute addressing work. Use GCC f no pi dash no pi to override this back of the old behavior. NoPy is the linker option. FNoPy is the code gen option. Okay, so NoPy is the linker option. FNoPy is code gen option. With only FNoPy, GC will make code like move EAX offset LC0 that doesn't link with the still enabled -pi. Clang can have pi enabled by default too. Use Clang FNoPy NoPy. A July 2017 patch made -NoPy an alias for NoPy. Noppy. Nope, Noppy. For compatibility with GCC, but Clang 401 doesn't have it. Performance cost of pi for 64-bit minor and 32-bit code major. We're not doing 32-bit anymore, really. With only NoPy, but still FPy. So we're generating position-independent code for 64-bit or 32-bit, but we're linking with NoPy enabled. Compiler generated code from C or C++ sources will be slightly slower and larger than necessary, but will still be linked into a position-dependent executable, which won't benefit from ASLR. Too much pi is bad for performance. Reports an average slowdown of 3% for AMD 64 on spec CPU 2006. I don't have a copy of the paper, so I don't know what hardware it was on. But in 32-bit code, the average slowdown is 10%, worst case 25%. The penalty for pi executables is mostly for stuff like indexing static arrays. As Agner describes in the question, we're using a static address as a 32-bit immediate, or as part of a disposition 32 plus index times 4. Addressing mode saves instructions and registers versus a RIP relative load effective address to get an address to the register. Okay, so you have to do an extra LEA to calculate the address and then get an offset from that address. Also 5-byte MOV R32 immediate 32 instead of a 7-byte LEA. For getting a static address into a register is nice for passing the address of a string literal or other static data to a function. FPy still assumes no symbolic interposition for global variables functions like, unlike fpic, what is fpic in GCC versus fpi? Sorry, fpi. I thought they were the same. Position independent code, position independent executable. Uses global offset table and a procedure link table, slightly more conservative indirect addressing required for shared libraries on x86-64. Pi is for executables. Makes sense. I wonder if Go's binaries are position independent. Okay, where do I want to put this thing? O3? No. I want to go to, here we go, chapter 03. Oops, please go away. It doesn't say it's a Pi executable. It's executable file, yeah. So that means that Go doesn't do address space layout randomization. If we do this test.go, it detects a deadlock though. Here, let's do another thing here. I never said it was a thread issue, dumbass. Oh, I can do build mode pi. Interesting. I wonder if it still says statically linked. That's not a good way to block. Well, let's go ahead and just open up test. You know what I'm gonna do? I'm gonna move this to be test sleep. Sorry, move test.go to be test sleep.go. And I will just do a sleep. PID. Get PID. Test sleep. We'll call this no pi. Statically linked, and readelf gives us what again? Gives us an exec. And if we run it, and we look at cat proc, was it 232336 maps? We look at the text section, which is here. Text segment, I should say, the initial load goes right there. Look at all this stuff here. Go to some weird shit, man. Heap reservation, heap reservation, immortal metadata, profiler hash buckets, heap index, scavenge index, page summary allocation, immortal metadata, GC bits, all spans, immortal metadata, page allocation index, page summary. How are they even providing this metadata to the kernel to know that this anonymous mapping is that thing? Yeah, it's a lot of stuff. A lot of maps. A lot more than I'm used to. And this is like text, read-only data, and data. I think that's what those are. I don't know what this is. Okay. So yeah, no ASLR on the text. It's just put straight in there. And then if we do this again, well, I don't need to do it again. I already know what it does. But I'm going to open up makefile here, and I'm going to copy this thing over here, and I'm going to call it pi. Said that there's a flag that I could use. Where is the build flag? Build mode pi. And I think I've used this before, the alternative build modes for shared objects and other things. Alright, let's see if that works. I need to update this to have the build mode pi here. Actually, you know what? I'll do file on it. So it says the pi executable. That's nice. It says it's dynamically linked though, which is very atypical for Go. And if I do a read elf all, I'll just do the header. Why not? It says it's dynamic with pi. And then if I run it, test sleep pi, and then I go over here, just copy this PID, cat out, proc PID, maps. Look at that. It's at some random address, but that's not the text section. This is the text section. So I actually got mapped in between these anonymous sections. It's interesting. This does seem to be a typical range that Linux puts the pi executables in this 5F range. If we do a grep here for, it'll be read xp like that. Sorry, grep. And grep for pi or sleep. There we go. And then if we go here, kill that, rerun it, grab the new PID, go over here, paste the new PID, delete the old PID, run it again. So you can see how the addresses have changed. Mac OS. I wonder if it's dynamically linked against libc. Let's do a kill on that LDD. No, it's still statically linked. When was Go 122 released? (2024) All right, enough of ChatGPT. I just hate that it's freaking so biased and frames things in such a politically correct way. Like, it's okay. Like, they want static binaries, and so they don't want to do the work on Linux because they want to do static pi instead of dynamic pi. But on Mac OS, they're more than willing to do dynamic pi by default because they're forced to. Apple has a dictatorship on that platform, and they force everyone to do everything their way. And their way, or it's their way or the highway, and their way is a dynamic position independent executable. And so they do that. If Linux did that, then they would be forced, if it wanted to run on Linux, they would be forced to do that. But Linux gives you choice. And because they have a choice, they choose not to do any of it. Even though position independent executable would be a benefit for security because of the ASLR on the text section and data and read-only data and all that stuff. BSS and everything. So yeah, that's where we're at with Go. You can do it, but when you do it, I guess it's fine. You just don't get it by default. And there is a performance cost, especially on 32-bit code for Pi. Well, RIP relative addressing, of course, isn't on a 32-bit because RIP is 64-bit. You mean EIP? There's just so much good information here. Oh, I can do a static pi, cool. 2017. All variable references and function calls. I think they're talking about global variable references and function calls indirect, unless they're static. Wow, time flies. Didn't get any time on the reading. I've just been reading these articles here. So it's relative to the instruction pointer. Why does it send you to the web archive? Like, why can't I go here? Why does it send me to the web archive? Okay. Maybe it's like they're just done hosting it, so they just say, hey, go read my shit on the archive. I'm tired of hosting my stuff. Okay. Well, let's do some commits here, I guess. Let's jump to learn log, vim up blogs, and I'm going to add to here. This thing, which is sorry state of dynamic libraries on Linux. And I'll fix up this thing here. Boop. Alright, before we push, I want to finish reading this. There's quite a lot left here. The compiler needed to generate the code above since it doesn't know where the symbols will actually be. As was the case before, those symbols can be linked into the same ELF module as the compilation unit, or they may be found elsewhere in another ELF module this one links to. Moreover, the compiler and linker need to deal with the possibility that an executable might have done exactly what our executable in the previous section did, create a copy relocation on the variable and fixed the address of the function to its own PLT stub. In order to work properly, code must deal with the fact that its own variable might have ended up elsewhere and that external function might have a different value. This means the indirect call through the PLT and the 3 movq instructions remain even if those symbols were in the same compilation unit. Interesting. The problem is that even if at first glance you think the compiler should know for a fact where those symbols are, it actually doesn't. The fpic option doesn't enable only position independent code, it also enables ELF symbol interposition, which is when another module steals the symbol. That happens normally by the way of copy relocations, but it can also happen if an LD preloaded module were to override those symbols. So the compiler and linker must produce code that deals with that possibility. In the end, we're left with indirect calls, indirect symbol address loadings, and indirect variable references which impact code performance. In addition, the linker must leave behind relocations by name for the dynamic linker to resolve at load time. It's cost of indirection that you don't want to pay, I guess. All this for the possibility of interposition. Yeah. Yes, it seems so. The impact is there for this little known, little used feature. Instead of optimizing for, I personally like that C programs are getting more able to do interposition because like manually patching code kind of sucks. But I don't know if I want to force people to do that, to have secure position independent code, or position independent executables or position independent code on dynamic libraries. Like you should be able to choose a more performant solution that doesn't require the interpositioning. Instead of optimizing for the common case scenario where the symbols are not overwritten, the ABI optimizes for the corner case. Yeah, they're right. They're right for sure. Another argument is that the ABI optimizes for executable code, placing the impact on the libraries. The argument is valid if the executables are much larger and more complex than the libraries themselves. It's valid too if we consider the application developers write sloppy code, whereas the library developers will write very optimized code. I don't think that argument holds anymore. Libraries have gotten more complex in the past 10, 15 years and do a lot of more than they once did. They're not mere wrappers around system calls. Like libc 4 and 5 were on Linux in the late 90s. Moreover, if we consider the rise of interpreted languages like Perl, Python, Ruby, even QML, and JavaScript, the code belonging to the ELF executable is negligible. Compare the size of the executables with the libraries that actually do the interpretation. Yeah, so how is Python only 9K? Is that really 9K? Perl, Python, Ruby. Oh, it's because they offload everything to the libraries. Okay, that's their whole point of what their statement here. Okay, that's even valid for interpreters that JIT the code. As optimized as the code they generate can be, current understanding is that operations with critical performance are implemented in native code, which means libraries or plugins. Existing solutions. Partial solution for private symbols. Boop, 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 boop. And again, this is like slightly dated here. 2012. When developing your library, if you know that certain symbols are private and will never be used by other library, you have an option. Shit. Okay, I guess I should wrap it here. I'll be on after I get dinner, grocery shop, do some cardio, and what else? There's something else I needed to do. Cardio, dinner, grocery shop, and take the garbage out. But yeah, I'll be back on. It's probably not going to be an hour, to be frank, but I'll try to get it done in an hour. And then I'll finish up reading this blog post. Probably won't read any of the Linux binary analysis tonight. But yeah, we'll finish up this blog post and some of the experiments we're doing. Cool. All right, I'll be back on in about an hour. Later.